Hey everyone, let's discuss the first problem from today's weekly contest, that is number of common factors. So we're given two positive integers a and b and we have to return the number of common factors of a and b. Fairly easy problem and we can easily calculate it using brute force, and it works in the contest as it is the first problem. But in this video we are going to discuss the most efficient approach to solve this problem, right? So what we'll do is we will calculate the GCD of these two numbers and we will calculate the divisors of that GCD. Alright, so let's see how we'll calculate the GCD of the two numbers. So the most efficient way to calculate GCD is using the Euclid's algorithm. Like, this is the most classical way to calculate the GCD in this algo. So let's see how Euclid's algorithm works. Basically, let's take the third test case only, 30 and 25. So what Euclid's algorithm says is, we are recursively calling this function and passing b in here and a mod b in here, right? And the base case is, if b becomes 0, return a. So basically, when b will become 0, a will be the GCD, right? We would have obtained the GCD of the two numbers, right? So we will take a and b here, all right, and then we will take a mod b here, okay, a mod b here, right? So we'll calculate, so we'll copy 30 and 25 in the first call, all right, and then what we want to calculate is 30 modulo 25, we will get 5, okay. Then we will copy this 25, we will make a recursive call copying this 25 here and this 5 here, okay, and then again we'll calculate a modulo b, which will be 0 in this case. Then we'll copy this 5 here again, okay, and this 0 here, right, this 0 here. So now we are gonna reach the base case because our second parameter has become 0, and that means a is the GCD of the two numbers. So basically, the time that this algorithm takes is log of minimum of a and b, all right, minimum of a and b, all right. So this is how we'll calculate the GCD of the two numbers, right? And then we are calculating the number of divisors of this GCD, right? So what are the number of divisors? Now the catch in this function is we are not iterating from 1 to n. Basically, we are calculating till square root of n. Now why so? Because the divisors always appear in pairs, right? For example, let's take 30 only here and let's discuss about it, okay. So let's say if we consider 30 and we want to calculate the number of divisors 30 have. So if we calculate, so the first divisor that we are going to get is 1, right? But if 1 divides 30, that means if 1 divides 30, so let's make this 30. If 1 divides 30, that means there is another divisor which divides 30, which is 30 in this case, and then let's say we have 2, then we'll get 15, right? And similarly up to, we calculate 3, and then for 6, and then we'll get 10, but 10 will already have been included in this call, right? Right here we'll have 3 and 10, so we'll not consider this. So we'll only calculate up till here, and that will be our answer. So that's how I've implemented this, and the time complexity that this function takes is square root of n. So this is how we can efficiently calculate the number of common factors of two numbers.